In this video, we're going to talk about an idea that we mentioned in our last video on box plots, and that's the idea of an outlier. Outliers are extreme data values that don't fit the pattern of the rest of the data. And we saw in that box plot that we had a little bit of concern that maybe 20 might be an outlier because 20, our maximum value, was way far out on the edge, really far from our third quartile. So we can identify potential visual outliers from a graph, looking for points in the graph that don't look like they fit the pattern of the rest of the data. They're really far from everything else. However, these are just suspected outliers. To confirm that they are truly outliers, I need to do some mathematical calculations, and I have two choices, depending on what I used as my measure of center and my measure of spread. If I'm working with the median and the IQR, a good rule of thumb is the 1.5 IQR rule. So the 1.5 IQR rule, we're going to calculate our lower and upper bounds by taking the first quartile and subtracting 1.5 times the IQR. And to find an upper bound, I'm going to take the third quartile and add 1.5 times the IQR. Data values that are below the lower bound are outliers. Data values that are above the upper bound are outliers. The other rule is for instances where I'm using the mean and standard deviation for my measures of center and spread. In that case, it's called the 2SD rule, or the 2 standard deviation rule. I'm going to take the mean and I'm going to subtract 2 standard deviations to form my lower bound. And I'm going to take the mean and add 2 standard deviations to form my upper bound. Data below the lower bound is an outlier. Data above the upper bound is an outlier. So we're going to go ahead and check a data set for outliers, and you can see I forgot to copy the data set. So we're going to go back up and bring our data set from the last example down. So we'll work with this data set. You'll notice in this example it said check for outliers using both rules. How do the results compare? So we want to look at the difference between how the IQR rule and the standard deviation rule identify outliers. So we'll start with the 1.5 IQR rule. So for the 1.5 IQR rule, I need Q1, I need Q3, and I need my IQR, which is the difference. We calculated those in our last example to build our box plot, so let's go back up to our last set of notes and check. So for this data set, we had quartile of 6, median of 8, upper quartile of 11. 6, 8, and 11. So quartile 1 is 6, quartile 3 is 11. And our interquartile range is 11 minus 6, which is 5. We're going to use those values to calculate a lower bound and an upper bound and check where our data sits relative to those boundaries. So for our lower bound, we're going to do 6 minus 1.5 times the IQR, which is 5. So I'm going to grab my handy dandy calculator and I'm going to go ahead and do that. So 6 minus 1.5 times 5. And let's see, I get negative 1.5. Looking at my list, my minimum is 3. I don't have any data values less than negative 1.5, so there are no lower outliers. No outliers on the low end of our graph. For upper bound, I'm going to take the third quartile, and I'm going to add 1.5 times the IQR. So I'm going to do 11 plus 1.5 times 5. And I get 18.5. 18.5 sits between 16 and 20. 20 is bigger than my upper bound, so 20 is an outlier. As we suspected from our box plot, 20 is so far away from the rest of the data, doesn't really fit that pattern. We're going to repeat this now for the 2 standard deviation rule. So for the 2 standard deviation rule, I need my mean and I need my standard deviation, Sx. So we're going to go ahead and use our calculator to find those summary statistics. So I'm going to go stat, enter. I'm going to clear out that first list. Maybe if my calculator cooperates. Clear, enter. And I'm just going to type those data values. My data's in list 1, so I'm going to run 1var stats on list 1. And you'll notice it gives me Q1 is 6, median is 8, Q3 is 11. That checks out. I'm going to scroll back up a little bit. And I can see that my mean is 9.2. And my standard deviation Sx is 5.3. Rounded. So we're going to go ahead and do our lower bound and our upper bound. For the 2 standard deviation rule, we take the mean for the lower bound and subtract 2 times our standard deviation. So on a calculator, we're going to do 9.2 minus 2 times 5.3. And I get negative 1.4. And our min is 3. So just like with our other rule, we don't find any lower outliers. Plural. I know how English works. For the upper boundary, same idea. The mean plus 2 standard deviations. So 9.2 plus 2 times 5.3, and we get 19.8. Going back up to my list of data, marking this upper bound in blue, 19.8 is a lot closer to 20 than 18.5 is, but it's still less than 20. 20 is over that line. So this rule also identifies 20 as an outlier. As a side note, if you look at where those limits are, the lower bound for the IQR rule was a little bit lower. The upper bound was also a little bit lower. Whereas here, negative 1.4 is bigger than negative 1.5. 19.8 is bigger than 18.5. That 2SD rule shifted our boundaries up a little bit on the number line. We're choosing based on what our distribution of data looks like. If you suspect that you have an outlier, or when you graph it, it looks skewed, this is the preferred check. If you graph it and the graph looks symmetric, then this is a better check. In our class, we're going to default to the 1.5 IQR rule, because generally if I'm checking for outliers, I suspect that they're there. I see something in my graph that makes me worry. And when I have significant outliers, the median and IQR are better measures of center and spread. So that's the rule I would use. All right, if you have any questions on how those checks for outliers work, let me know via email or drop by office hours. Otherwise, I'll see you in our last video for week 1.